This is a call for fundamental reform in contemporary physics. For those more mathematically inclined, and who have more time to ruminate over the details, defying the short attention span, here's an argument with formulae, demonstrating that Einstein's so-called theory of relativity is flawed. The entire so-called theory of relativity, which some divide into special and general, put forth by Einstein, is contained in paragraph 1 and paragraph 2 of his 1905 paper, published in Annalen Physik. The rest of the paper is dedicated to unsuccessful application of the known Lorentz transformations to various physical situations. It is not even necessary to analyze these applications. Once it becomes clear, as is shown in this presentation, that the so-called theory is not only flawed but it isn't even a theory, because it is internally contradictory. It isn't even wrong. Therefore, Einstein's so-called theory must be removed from science in its entirety without delay. The main claim of Einstein's so-called theory of relativity is presented in paragraph 2 of his 1905 paper, and concerns relativity of simultaneity. He falsely claims to have proved that simultaneous events in one system are not simultaneous when viewed from another system, moving with respect to the first. We will demonstrate here that this claim is false. According to Einstein, the classically derived inequality found in the stationary system, capital K, as opposed to the equality shown below, also classically obtained, is taken as proof that simultaneity is relative. It is shown here that both the equality and the inequality in question are trivial outcomes of classical physics and its simplest trivial definition of velocity. Their juxtaposition can by no means serve to judge for the simultaneity of two events. If the comparison of these two classically obtained inequality and equality is to be used, which it should not, as a criterion for simultaneity, then it is elementary classical physics, not Einstein's theory of relativity, that would derive relativity of simultaneity. As said, using these expressions for the purposes of determining whether or not two events are simultaneous is inappropriate. Therefore, elementary classical physics makes no profound discovery regarding simultaneity, and simultaneity is still absolute. That is, simultaneous events in one system are simultaneous in all systems, moving or not. First of all, what are these quantities T sub A, T sub B and T prime sub A? T sub A is the time value of an event, flashing of light at spatial position A, expressed by the positions of the hands of a clock placed at A, which positions are simultaneous with this event, flashing of light at spatial position A. T sub B is the time value of an event, arrival of a ray of light at spatial position B, expressed by the positions of the hands of a clock placed at B, which positions are simultaneous with this event, the arrival of a ray of light at spatial position B. T prime sub A is the time value of an event, arrival at A after the ray of light has been reflected at B in the direction of A, expressed by the positions of the hands of a clock placed at A, which positions are simultaneous with this event, namely, flashing of light at spatial position A. We will start the analysis by illustrating that all clocks in the stationary system, capital K, are synchronous even by criterion T sub B minus T sub A equals T prime sub A minus T sub B. Further, we will see how the inequality is derived, which Einstein ascribes to the moving system, and bases his entire so-called theory on. Thus, firstly, we will derive the expression for the time interval t sub b minus t sub a of the travel of the photon from end A to end B of the main device, a rigid rod, which Einstein uses to quote back his claim. At the initial time t sub a, both photon and the end A of the rod have the same coordinates in the stationary system, capital K, namely A of t sub a, respectively, f of t sub a. The end B of the rod at time t sub a has a different coordinate, namely B of t sub a. At some intermediate time, that is, time before the moment the photon reaches end B of the rod, the coordinates of the photon and the beginning A of the rod no more coincide, because the photon travels faster than the rod. The positions of A, B, and the photon are determined by adding to their already known initial positions at time t sub a the distances traveled. The distances traveled obviously are the products of the corresponding velocities and the time elapsed to reach the point shown in the diagram. This is straightforward, and the corresponding expression can be seen written next to the coordinates of interest. At time t sub b, that is, at the moment the photon reaches the end B of the rod, the expressions for the coordinates of the points of interest are exactly the same as the expressions we just wrote for any time t. Here, instead of any time t, we substitute the concrete time t sub b when expressing the time elapsed. So, again, there's nothing unusual in the expressions written in the show diagram near the coordinates of interest. Now, once we are comfortable with the obvious expressions for the coordinates of the points of interest at time t sub b, we realize that we can express the length of the rod, r sub ab, as the difference between the coordinate of the end B at time t sub b and the coordinate of end A at this same time t sub b. Pay attention to the little animation. Obviously, when writing the expression for the length of the rod, r sub ab, we may substitute the position of end A at t sub b by the position of the photon at t sub b. We can do this obvious substitution because at time t sub b, the position of the end B of the rod and the position of the photon coincide. The animation reflects that substitution. But then we can substitute the explicit expression for the position of the photon at time t sub b and the explicit expression for the position of end A at time tb into the expression for the length of the rod r sub ab. A lucky circumstance, namely, the fact that at the initial time t sub a, the coordinates A of t sub a and f of t sub a coincide, allows cancellation. And we get what we needed to prove. Here we will also add the extremely important expression, in which the length of the rod, r sub ab, is given explicitly as the difference between the coordinates of end B and end A at time t sub b. Notice very carefully that both coordinates are evaluated at exactly the same time, t sub b. This shows that both end A N and B undoubtedly coexist in the stationary system, capital K. Because of its importance, we will repeat the last observation. This result is of exceptional importance for the current analysis. It shows that the time, measured by the clocks placed at the two ends A and B of the rigid rod, is one and the same T sub B, equal to the time T sub B of the synchronous clocks in the stationary system, capital K. This means that the clocks at A and B, at rest with the moving system lowercase k, are indeed synchronous. Here is an animated illustration which will help in understanding that the two clocks at rest with the moving system, lowercase k, are synchronous, as are the clocks in the stationary system, capital K. The obvious fact that two spatially coinciding clocks must be synchronous had been admitted explicitly by Einstein in his 1905 paper. The fact that two spatially coinciding clocks are synchronous proves directly that the clocks at A and B at rest with the moving system, lowercase k, spatially coinciding with the synchronous clocks in the stationary system, capital K, are also synchronous in the moving system, lowercase k. Again, clocks at A and B in the moving system, lowercase k, are synchronous. This is a direct quote from paragraph 2 of Einstein's paper. Quote, "We imagine further that at the two ends A and B of the rod, clocks are placed which synchronize with the clocks of the stationary system, that is to say that their indications correspond at any instant to the time of the stationary system at the places where they happen to be. These clocks are therefore synchronous in the stationary system." Unquote. Indeed, the indications of these clocks, attached at ends A and B of the rod, do quote, correspond at any instant to the time of the stationary system at the places where they happen to be. This result, not noticed by Einstein, is of utmost importance, and therefore it has to be strongly emphasized once again. Therefore we will repeat that it is an absolute truth, inherent in the very definition of velocity, as seen in the formula just derived, that clocks at rest with a moving system are synchronous. As seen in the formula, the time read both on the face of the clock at end A and on the face of the clock at end B, both at rest with the moving rod, is one and the same. That is, T sub B. This fact that the clocks at both end A and end B, at rest with the moving rod, are synchronous, we will use at the end of this analysis. Interestingly, however, we don't even need to wait till the end of the analysis, because even at this point we can see at once, from the formula just derived, adopted by Einstein, that the second postulate is violated. In the formula, derived above and used by Einstein as one of the two formulae to, quote, prove relativity of simultaneity, the quantity T sub B minus T sub A is exactly the time interval for which nothing else but light travels from the one end A to the other end B of a rod, having length RAB. Therefore, the meaning of the quantity c minus v in the denominator can only be velocity of that light. This is in direct contradiction with the second postulate, requiring the velocity of light to be constant under all circumstances. According to the second postulate, it should be of no significance whatsoever whether or not the rod moves when the light travels from its one end to its other end. The distance RAB, which is the length of the rod, should always be traveled by light. with one and the same velocity c equals constant, which according to the second postulate, should be the velocity of light when traveling along any distance. The distance traveled by light should have no significance. If the velocity of light is postulated to be always c equals constant, then every distance, including the distance RAB, must necessarily be traveled by the light with velocity c equals constant, and not with velocity c minus v, or with velocity c plus v, as the formula adopted by Einstein suggests. We can stop right here and not waste any more time on the purported theory so obviously incorrect. It may be instructive, however, to explore the entire argument, to remove any doubts that there may be anything in it, which won't be revealed if it isn't followed till the end. Here goes. Here we derive the time interval t prime sub a minus t sub b of the reverse travel of the photon from B back to A. The derivation in the reverse sense is the same, except that the starting point now is the position of the relevant points at time t sub b. For the intermediate time t, the expressions for the reverse sense differ, in that they represent decrease in distance at time t prime a. We again use the general expression for the position, but this time only at the beginning of the rod A and the photon, substituting in this general expression the current time t prime a. Position of A and photon coincide, therefore, we may make their expressions equal each other and do some rearranging. The shown inequality is as seen above, a true, perfectly derived inequality, using primarily the definition of velocity, derived in the stationary system, capital K, but valid also in the moving system, lowercase k, through the synchronicity of spatially coinciding clocks, explicitly admitted and used by Einstein himself, as well. On the other hand, the expression shown here is also a perfectly legitimately derived correct expression, but it indicates, as was already pointed out more than once, that the two clocks at A and B in the moving system, lowercase k, are synchronous. However, if the clocks at A and B, at rest with a rigid rod, are synchronous, as they are, but lead to the inequality seen here, then it is not possible for the speed of light to be constant, as Einstein's so-called theory of relativity postulates, as its second postulate. Recall. If two synchronous clocks, both at rest with a system, such as the clocks at ends A and B of the rigid rod, measure shown times intervals as unequal, then it is not possible for the speed of light to be constant as postulated by Einstein. Einstein's second postulate is in internal contradiction with elementary, impossible to be questioned, absolute truths in physics. This invalidates the second postulate of Einstein's so-called theory of relativity, as well as the theory as a whole. The above analysis shows that Einstein's so-called theory of relativity has no place in science. The so-called theory in question, as well as any outgrowth of it, must be removed from science without delay. This is a call for fundamental reform in contemporary physics.